Okay, so starting off with our first lesson, chapter number 1, okay, where we will be studying data representation, okay. So there is quite a lot that needs to be done in this chapter. We'll be going through it one by one, okay. So initially starting off with what is a computer, let's scroll down, okay. So if you go through our tute and if you scroll down in page number 1, it talks about what is a computer, okay. So if you look at the first part, it's talking about the computer being an electronic device, okay, a device that has to be connected to an energy source, okay. So it needs to be receiving current from a source. It can be a battery or it can be connected to the mains, for example, okay. So any computer is an electronic device, okay. Right. Now, what I want you all to look over here is I want you guys to look at this diagram that has been given over here, where you can see data, process, information. This is where I'm going to spend some time on, okay? So over here. So if we were to talk about this diagram over here, and if we were to look at it over here, what I want you guys to remember is something very important, something that every computer follows, okay? Every computer follows something known as the, let me get this down, known as the IPO cycle, okay? Something known as the IPO cycle, okay? This is something that every computer follows, okay? So if we were to define this IPO cycle, if we were to define what it stands for, okay? It stands for input, okay? So the first step is input, okay? Something is given to your computer, something is entered into your computer. Step number 1. After input, the next step that happens is something which is called process, okay? So the next step is process, input, then your computer tries to understand what you just told it. And after process, the next step that happens is something known as output, where your computer will respond to your input, okay? Now, one more thing that needs to be added is when the process is happening in your computer, when your computer is handling with this process, okay, it will also deal with something known as your memory. Is it clear? Your computer will also be dealing with something known as your memory, okay? So this is what we call the IPO cycle. This is basically what we refer to as the IPO cycle. And this is a cycle, okay, that every single computer follows, okay? Every single computer, there is an input. Then there is something in your computer that tries to understand your input. While it tries to understand what you just said, it will be accessing your storage, okay? I'm sorry. And thereafter, it will be giving you an output, okay? So the output might be something that you see, it might be something that you hear, or it might be a hard copy, like a printout, for example. Okay, so this is how every single computer functions, okay? Every single computer, this is the cycle it follows, okay? Now, if we were to look at input, okay? If we were to look at input, guys, okay? Let us first see what are some of the devices that you would be using, you as the user, what are some of the devices that you would be using in order to give input to your computer? Okay, so some of the devices you would be giving is just think about some of the input devices that you know of. Okay, so yes, you can start off with, for example, the mouse. Okay, the mouse is one of the most basic input devices you can think of. Okay, so using the mouse, you can give instructions to your computer. You can click on something, you can open something, okay, using your mouse. Okay, then another input device that you can talk about is something known as the keyboard. Okay, so using your keyboard, you can give instructions, you can give input to your computer. You press the key, you're giving input to your computer. Okay, another input device that you can think of is mouse, keyboard. Another one can be, for example, a joystick. Okay, something else can be a microphone, for example. So if you want to give voice instructions to your computer, you want to send your voice. So for example, right now, as I'm recording this lesson, I'm using a microphone to collect my voice. Okay, my voice is being received into this computer using a microphone. Okay, in addition to a microphone, you can also mention a webcam. Okay, a webcam is also an input device. It's taking my video. Okay, so these are a few of the input devices that I have listed over here. Okay, so in the IPO cycle, when it comes to input, these are some of the devices that your computer will be using in order to accept input from you. Okay, right. Then the next step is process. The next step that we are dealing with now is known as the process. So process is just like how when I tell you something, your brain tries to understand what I just told you, isn't it? When I tell you something, your brain tries to understand what I just told you. The same thing happens in the computer. So in the computer, when you give it an instruction, when you use an input device and give an instruction to your computer has something known as a processor. Okay, so let me put it in small letters over here. So we have something called a processor. Okay, or sometimes it is referred to as a chip because it's so small in size yet so powerful. Okay, so this processor will basically understand, it will try to understand the input that you have just given the computer. Is it clear? So this is what we call the process, and the process is done in a part called the processor. Okay, now while your computer is trying to understand what you just told it, your computer is trying to understand the input that you just gave. Okay, so if, for example, you pressed a key, you double clicked on something, you said something to your computer, for example, now your processor is busy trying to understand what you just said. Now remember, while your computer is trying to understand what you just said, it will be accessing your memory. Okay, so for example, whatever memory device you have in your computer, your processor will be communicating with it continuously. And it will be communicating both ways, where the processor will be sending data to the memory and the memory will be sending data to the processor. It happens both ways. It's a two-way street. Okay, so if we were to talk about memory, guys, what are some of the storage devices that you can think of? Okay, so initially one storage device you guys would tell me is, yes, the hard disk. Okay, so for example, if you were to look at a laptop, for example, if you were to look at a laptop or a desktop, it would most probably have a hard disk. Okay, if not for a hard disk, most probably it would have a solid state disk. Okay, so we call this SSD. Okay, or it may have a pen drive. Okay, or for example, it might use RAM, or it might use ROM. Okay, what does it stand for? We will be talking about all this in the other chapters. Okay, random access memory, read-only memory. So these are some of the storage devices your computer will be accessing when it is processing your input. Okay, when your processor is processing your inputs, it will be communicating with one of these storage devices. Okay, now once your computer has understood your requirement, it has understood your input, it has understood what you want, then the final step is what we call output, where your computer will be then giving you something as in it might display something to you, or it might make a sound, or for example, it might give you a hard copy. Okay, so in various forms, it will be giving you an output. Okay, so if we were to look at some of the output devices, okay, you would find, for example, we can start off with monitor. Okay, monitor is an excellent example for output. Okay, so you press, let's go in that sequence. Okay, so using your input device, the keyboard, using the keyboard, which is an input device, you press the letter A. Then what happens is your processor processes what you have pressed. And then on the monitor, the monitor is an output device, you would see the letter A appearing. But it happens so fast, okay? Within a split second, it happens. Okay, it happens very, very fast. Okay. Another output device we can talk about is a projector, for example. Okay, so a monitor is, if example, if one user is using, a monitor is enough. But if you have multiple users using it, you will require a projector if you have to display something to multiple users, a large audience. Okay. Then, for example, you can talk about speaker. Okay, you can talk about headphone. So these are output devices that would make a sound. Okay, it would give out a sound. Okay, then for example, you can talk about a printer. So this is an output device that would give you something physical. Okay, so for example, you have a soft copy on your computer. Using your input device, a keyboard, you give an input. Okay, Control P, enter. Then your processor tries to understand what you have just pressed. And then your printer will give you the output where the printout would appear. Okay, so this is what we refer to as the IPO cycle, and every single computer follows this cycle. Okay, all computers follow what we call the IPO cycle. Okay, so there is input, there is a process, and while processing, it communicates with your memory, and thereafter it delivers an output. Okay, there is something else as well that I would like to add over here. So when we say input, basically what happens is we are giving data to our computer. Let me erase this. I'm just explaining a little further. Okay, so normally what happens is you give data to your computer. Okay, you press a key, you press a button. Okay, you say something. Okay, this is data. It does not make sense. Okay, by just pressing one button, it doesn't make sense. Okay, so you give data to your computer. You click on something, you press a key. Okay, so you give data to your computer. It's something that cannot be understood. It is raw facts. Okay, what your computer will do is your computer will process the data that you just gave it. Okay, the data that you just gave, your computer will try to understand. It will try to process it, and after it processes it, what you get is something which we call information. Okay, so data is something that cannot be understood. It's raw facts. Okay, your processor will process it. It will try to understand it, and then it gives you information, something which you can understand. Let me give you a very simple example. Okay, so say for example, using your mouse, you go and double click on Microsoft Word. Now you moving your mouse is data. The cursor is moving. Okay, and then you going and double clicking on Microsoft Word is data. It's just the button being pressed twice. Okay, button being pressed twice doesn't tell you much. It doesn't make sense. Mouse left button has been pressed twice. What does it mean? Okay, but what happens is your processor will try to understand where did you click, how many times did you click, what was the program you clicked on. Okay, your processor will try to understand all these, and then what happens is it will show you Microsoft Word opening up on your screen. Is it clear? So you gave your computer data. You just gave it raw facts. You just double click twice. That's all you did. You pressed the button twice. This was raw facts you gave your computer. Your processor understood where you clicked. What does it mean when you click in that specific location? What is the program there? Your processor understood this, and thereafter your processor will tell the monitor, okay, show Microsoft Word to the user. So when Microsoft Word opens up on your screen, you understand that display. So we call that information. Okay, so this is the basic IPO cycle. Okay, where you have use input devices to give data to your computer. Okay, using input devices, you give data to your computer. Then your computer processes it. While processing it, your computer will communicate with memory. Okay, and thereafter it will give you a output. Okay, it will either make a sound, it will display something, it might give you a printout. Okay, so this is what we call the IPO cycle, and I'm reminding you guys again, this is how all computers work. Okay, so I hope it makes sense. Okay, this is the first thing that we have to learn when we come to this the topic of computer science. Okay, now some of you may be wondering, well, I do not know some of these memory devices, I do not know some of these output devices, I do not know some of these input devices. Well, no worries. Okay, we will be learning a lot more about each of these devices in the next few chapters. Okay, for now, all I want you to know is how does a computer work. Okay, I want you guys to know about this IPO cycle over here. This is what I want you to know about. Okay, how a computer works, it follows an IPO cycle, and this is what an IPO cycle is. Okay, that's it for now. Okay, right, moving on then. Moving on to our next part. The next part. So we have spoken about this area. Okay, this area we have spoken about it. Okay, let's scroll down a little bit. Let's scroll down to the next page. Okay, so when you come into the next page, okay, it talks about what happens inside the computer. Okay, it's talking about what's happening inside your computer. Okay, so over here it says inside every computer is a processor. Okay, so by now you should be knowing the function of a processor. The processor accepts input and then gives you output, or the processor converts data into information. Okay, by now you should be knowing this. We just spoke about it. Okay, right. Now, if you were to look at point number 3, okay, I want you guys to look at point number 3. It says the processor stores the data using electrical switches that can either be on or off. So when it comes to storing data in your computer, your data is stored in the form of electrical switches. Okay, where some are on, some are off. Is it clear? If it's confusing, don't worry, we are still getting there. Okay, so your data is basically stored in the form of your data is stored using electrical switches. I'm sorry, your data is stored using electrical switches, and these switches can be in 2 states, either they are on or they are off. Okay, right. Now, a switch that is on will conduct electricity, and a switch that is off will not carry any electrical signal. Okay, this is basic stuff. Okay, now we come to the word binary. Okay, we come to this word binary. Okay, so what does binary mean? Binary means anything that can be in any of the 2 different states. So when we say binary, we are talking about 2 states only. Okay, so when we say binary, we are referring to 2 states, and those 2 states are either on or off. Okay, so I'm repeating myself again. When we say binary, we are talking about two states, on or off. That's it. There is nothing else in it. Okay, right. Now, the data inside the computer is stored in binary format. Okay, so all the data that is stored in your computer is stored in this binary format, where data is stored in the form of electrical switches that are either on or off. So they have a kind of a pattern. Each piece of data has a pattern, okay, of where electrical switches are on or off. Okay, so this is what we refer to as binary. Okay, if you're still confused, do not worry. We are going a little more ahead. Okay, things will start making sense as we go along. Okay, right. Okay, so right now we have spoken about what happens inside the computer, and we have spoken about how your data is stored in the computer. Okay, right. Now, moving on, moving on. Now, what we are going to do now is we are going to slowly approach how do we understand this binary system? This binary system that the computer is using, humans don't directly use it. Okay, we do not directly use it, but the computer is using it. So in order for us to use the computer effectively, okay, because we're studying computer science right now. So we're studying how does the computer operate? How does the computer function? That is what we are learning in computer science. So we will start learning how does binary work? How do we read the binary language? How are numbers represented in binary? That is what we are going to be learning in this chapter. Okay, so slowly but surely we will get there. Okay, now before we talk about the binary number system, before we talk about the binary number system, before we talk about on and off and zeros and ones and things like that, before we talk about that, let us first properly understand the number system that we humans use on a daily basis. The number system that we use, okay, the system that we use for the numbers that we understand, let us first properly understand how that works so that we can use that logic in the binary number system. Okay, so the number system that we use, okay, the number system that we use when it comes to our addition, subtraction, multiplication, division, the maths that we use is known as the decimal number system. Okay, this is the number system that we use. Okay, as human beings, this is the number system that we use. So how does this number system work? This number system, okay, this number system has digits. It has digits from 0 all the way to 9. Okay, so you have 0, then you have 1, you have 2, you have 3, you have 4, 5, 6, 7, 8, 9. Okay, so if you were to count these digits, you would notice that there are 10 digits. Okay, if you start from 0 and go all the way to 9, you would notice that this decimal number system that we humans use, it has 10 digits in it. Okay, it starts from 0 and goes all the way up to 9. Okay, so in computer science, there are many number systems. Okay, right now we are learning the first one, which is the decimal number system, and this is the number system that we humans use. Okay, but in computer science, there are there are three number systems that you have to learn of. Okay, so when you write a number in computer science, okay, when you're writing a number in the computer science exam or in the computer science past paper, you have to tell what the number is. Is it a decimal number, or is it a binary number, or is it a hexadecimal number? You have to mention that. Otherwise, the person who is reading it might not be sure what type of a number are you talking about. Okay, so this applies only in computer science. Okay, for example, if you're doing mathematics or physics, you don't need to mention what number system you're using because it doesn't matter in those subjects. But in computer science, where you have 3 different number systems, you must mention what is the number system you're using when you write a number. Okay, so say for example, guys, say for example, you write the number 25. Okay, say for example, you write a very simple number 25. Okay, now if you are writing this number 25 in the decimal number system, okay, this number 25, you're writing it in the form of the decimal number system, you should put a 10 as its base. Okay, at the bottom, okay, after the 5 at the bottom, just put a 10. So when the user sees this 10, he immediately understands, okay, this is a decimal number. Is it clear? I'm repeating myself again, like I told you all previously, this applies only in computer science, because in computer science, there are 3 different number systems you will be dealing with. Okay, so when you write a number in computer science for your exam paper or for your, for your homeworks or for your assignments of computer science, always make sure you mention what number system you are referring to. Okay, so I have put 10 over here. So the person who's reading this immediately knows, this is a decimal number. Okay, right. Now let's move on to the next part. Let's move on to the next part where how do we read decimal numbers? Okay, now if I give you a number, you will very simply, if I give you a number like this, for example, you will immediately tell me, this is 1250. You got so used to reading numbers. But there has to be some logic in how these numbers is formed, right? Because when you understand the logic in how these numbers are formed, that same logic you can apply it in binary. Then it becomes very easy for you to understand binary as well. Okay, so let us understand how do we get 1250. Or for example, if I write a number like this. For example, if I was to give a number like, for example, let's take a number like 255. Okay, so if I was to give a number like this, you would immediately be able to read it. You would immediately say, you would immediately tell this is 255,650. Okay, you know how to read it, but there's a certain logic in how this number came together. Okay, how did it come to 255,650? How did this number come to 1,250? There is a certain logic, there is a certain way that the number is formed. Okay, so that is what we are going to be learning now. Okay, how do we form this number? What is the logic behind it? So that that same logic we can apply when it comes to reading binary numbers as well. Okay, right. Let me erase this. Okay, right. Okay, so I want you guys to look at this table that is over here. Over here, we have a table. Okay, so what I want you to do is we have taken the number to 25,177. Okay, we have taken the example of the number 25,177. Okay, so in this table, I have written the number. As you can see, I have started 25177. Okay, I have written the number 25,177 has been written. Okay, now we start from the right hand side. Okay, from the right hand side, that is the last number. We start from there. Okay, and what we do is we give it something known as position values. Okay, we give it something known as position values. Let me write that word over here because I'll be regularly using it. Okay, we give it something known as position values. Okay, so the position value on the rightmost end, the position value at the rightmost end is 10 to the power of 0. Is it clear? It's 10 to the power of 0. Why did we take 10? Because we are using the decimal number system, and in the decimal number system, there are 10 digits. Okay, that is why we have taken it as 10 to the power of 0. Okay, I hope it makes sense. Okay, so what we do is when we write the number, we start from the right hand side, the rightmost end we start, which is over here. We start from over here. Okay, and we give it position values. Okay, so when we give position values, we start with 10 to the power of 0. Okay, so why did we take 10? I'm repeating myself again and again. The reason we took 10 is because we are using the decimal number system, and in the decimal number system, there are 10 digits. That's why we took 10 to the power of 0. Now, 10 to the power of 0 is equal to 1. Okay, you should know this. Okay, this is maths. 10 to the power of 0. Anything to the power of 0 is equal to 1. Okay, then we move on to the next position. Okay, now we move on to the next position. You can see just now I made it red. We now move on to the second position. Now the first position is done. Now we move on to the next one. So that becomes 10 to the power of 1. As you can see, 10 to the power of 0, we just finished. Now when we come on to the next step, it becomes 10 to the power of 1. 10 to the power of 1 is equal to 10. Okay, so the second position, the value of the second position, is 10. Okay, now let's move on to the third position. The value of the third position is 10 to the power of 2. Okay, and how much is that equal to? That is equal to 100. 10 squared is equal to 100. Okay, then let's move on to the fourth position. Okay, let's move on to the fourth position. The fourth position is 10 to the power of 3. How much is that equal to? That is equal to 1000. Now let's move on to the fifth position, which is the final position for this number. Okay, let's move on to the fifth position, which is the final position. That is 10 to the power of 4. Okay, the position value for the fifth position. Okay, the position value for the fifth position is 10 to the power of 4, which is equal to 10,000. Okay, 10 to the power of 4 is equal to 10,000. Okay, so if you were to just look at this table of position values, you would notice that they keep doubling. Okay, one, not doubling, they keep getting multiplied by 10. So 1 became 10, 10 became 100, 100 became 1,000, 1,000 became 10,000. Okay, they keep getting multiplied by 10 as their position value increases. Okay, now what we do is, we take the value we have. Okay, now these are the values we have now. Okay, so for the number 25,177, these are the values we have, 25177, isn't it? So now what we do is we take the value, okay, we take the values and multiply them by the position values. Okay, so what we have done over here is, as you can see, we have taken 7 multiplied by 1. Okay, over here we have 7 multiplied by 1. Okay, then if you move on to the next one, you would see we have 7 times 10. Okay, so we are taking the value, multiplying by the position value. Move on. Now we have 1 times 100. You can see we have done that over here. Then we have 5 times 1,000. Okay, that's what we have done over here. Then we have 2 times 10,000. That's what we have done over here. Okay, so we have taken the value and we have multiplied it by the position value. Okay, then when you add all these values after multiplying them, so 7 times 1, you get 7, 7 times 10, you get 70, then you get 100, you get 5,000, 20,000. Once you multiply them and then when you add them all, you will get 25,177. Okay, so this is how we get 25,177. This is the logic behind when you write this number 25,177. How did we get it? This is the logic behind it. Okay, so this same logic of value and position value, this same logic, multiplying, adding all of them, this same logic, we will be applying it when it comes to the binary number system. Okay, so I hope it makes sense on how we calculate decimal numbers. Okay, now decimal numbers, what I mean is how the decimal number system works. I hope it makes sense on how the decimal number system works. Yes, you are going to be a little confused because normally you would just read a number. Now I have told you a method on how the number is calculated. Okay, so yes, you might be confused and that's normal. Okay, but as we keep going, as we keep trying different number systems, slowly but surely things will fall into place. Okay, right. So next we will be moving on to the binary number system. Okay.